going to talk about accessibility today. It's not something that comes up that often at conferences, but I have heard a few mentions so far, at least yesterday at JSConf, which got me pretty excited to hear people talking about accessibility. So just a show of hands, how many people are familiar with Shadow DOM? Quite a few. Cool. That's awesome. So we're going to start with a story. So imagine that you are working at a company that's a little behind the times. They're losing engineers because the people are pretty cool, but the work is really boring. It's really stale. You don't get to do anything modern. It's like you're supporting IE7, and it kind of sucks. But you are in a really good position at this company, and they have trusted you to pick the technology for a new project. They've said it can be super modern. You don't have to support IE7 or IE8 or IE9. So that's awesome. They've given you this trust, and you get to pick something. You start thinking, man, like everyone's been talking. There's so many cool things out there right now. And you think, web components. I've heard of that. That might be pretty cool to work into a project because we're only supporting the most evergreen of browsers, which means that they update themselves, and we can use a polyfill, and that sounds awesome. I think I'm going to do that. So you get to work on this project. It's like the best project ever. You get to your cool workstation. Finally, the quality of the work aligns with the kind of work that you want to do and the kind of work at a company that you want to work at. So you go to your job every day, and you work on this amazing project. It's super cool. A couple months goes by, and you need to present this project. So a couple things about this company. They hire people with disabilities. And you have a really awesome project manager who is blind. And she uses Microsoft Project along with JAWS, which is a screen reader. It actually stands for Job Access with Speech. I actually didn't know what that stood for. But she can do her job effectively if she is supported by the technology that she needs. So she'll be in the audience. Also, your CEO can't use a mouse. So you have some requirements in your audience for this internal project. You've chosen technology that you're not really sure if it's going to work for them. So when you go to present it, are you going to be a hero, or are you going to be sent back to the drawing board because you didn't consider your audience? So we'll have to find out. So before we answer that question, we're going to do some accessibility background, just refresh our memories of what accessibility is about, how you can make your projects more accessible. We're going to talk about what is the big deal with web components. Everybody's been talking about them. Sounds like most of us have heard of it, but we'll talk about what that is specifically. We're going to talk about Shadow DOM, which is one part of web components. And then we're going to talk about the accessibility situation of web components. And then we'll answer that question about if you're a hero or a zero. So when you're creating things that are accessible, or any projects actually, who are you building it for? I think sometimes we forget that everybody has a different ability, and it seems like some people aren't actually building projects for people, which I find pretty peculiar. So I just want to remind us all that we're building things for people, and we all have different abilities, so it's important to keep that in mind. In accessibility, there are some traditional groups of people that we talk about, and that includes blind and low vision. There's people who they can see, but maybe they can't see very far, and they look at their phone really close to their face. All different kinds of visual impairments, deaf or hard of hearing. So if you have video, you need to provide captions. Physical disabilities, there's a huge range of those as well. Color blindness, which affects a lot of people. And then cognitive impairments, which are a little more challenging, but if you can make the copy in your project read a little more understandably, you kind of cut down on the marketing speak, you can make something more understandable to someone with a cognitive impairment. But really, that includes everybody. So maybe you broke your arm and you can't use a mouse for a temporary period. Or maybe you had LASIK eye surgery and you can't see for a little while. Like, we have these different abilities that come and go. Some people have to live with them forever. So it's important to remember that not everybody can use a mouse or see the screen. So I wanted to find a persona that we could focus on a little bit. And I remembered that Stevie Wonder is blind. Maybe I could find a picture of Stevie Wonder. So I went and looked for one, and I found this, which is a picture of a goat. His name is actually Stevie Wonder, because he's a blind goat. So I went, all right, I like goats. I'm going to go with that. I'm going to pick Stevie Wonder. And we're going to look at this graph I have up on the screen that describes the assistive technology process. And there are multiple assistive technologies, but the one we most commonly talk about is a screen reader. So in this diagram, we're seeing Stevie Wonder. He interacts with a web browser, or in the case of our project manager, Microsoft Project, so some software application. That software application then interacts with another application, which is a screen reader in this case. And they talk back and forth via an accessibility API. And there are multiple APIs, but there are some tricks we can do to make that transfer of data more understandable. So this graph is just indicating to you that there's some interaction between the web browser and the assistive technology. So that was the goal of this. But Stevie Wonder relies on his screen reader to tell him what's on the screen because he can't see it. So in an ideal world, we should have everything work from the keyboard. Have you ever navigated a website without a mouse and you gave up and started using the mouse because you could? You tried using the keyboard, you're tabbing through, you don't know where you are, maybe you got trapped somewhere. You gave up because you could, but what if you couldn't use a mouse at all? Part of what makes this better that we should do, this is some low-hanging fruit stuff that just applies to any website that you build, is that we should provide good visual feedback. It's really helpful for everybody if you, along with a hover state, you define a focus state. Pretty easy, right? Another thing you consider is a logical tab order. If you tab through a web page, what is the order of elements that you see as you focus throughout the screen? It should go in a linear fashion. Just, no matter what your layout looks like, it should be logical. It shouldn't jump all over the place. So keyboard navigation is pretty important. If you have stuff hidden away in a mega menu, you should be able to get there from the keyboard. You shouldn't prevent people who can't use a mouse from navigating your website. So with screen reader access, meaningful page structure is really important. So you want to consider the outline of your document, not just the way it looks. You should pay attention to semantics. You should use headings. You should think about, what is this document? What am I trying to convey? And what is the best HTML that I could use to communicate what is on the screen right now? You should have relevant non-visual content. So if you have images, you need to explain what they are. Especially in the case where we used to embed text into images, we have to provide that text off screen somehow. You have to make it usable without seeing, basically. It's pretty important. If you can't see the screen, you should know what's on it. But we forget that sometimes. Some general accessibility things that we should remember. Color contrast. That's a huge population of people who can't see some of your text because it doesn't stand out enough over the background. On this slide, actually, I had some gray text where it says, "in an ideal world." And I figured that probably wouldn't be readable because of this monitor, so I changed it. And that's something that we should consider. Is your text going to be readable based on the colors that you've chosen? We should make experiences interactive and accessible. So just because you're making it accessible doesn't mean it has to be text-only and boring. You can script it so that it's interactive using the keyboard. It's really important that we consider the user experience. SEO and accessibility are BFFs. I like to think of that, it's a good way to sell accessibility, actually, if you can say that there's more than this small niche audience that you're considering. Actually, Googlebot is the world's largest blind user. Because Googlebot can't see the screen, it also needs relevant text content. So that's a win if you can make your content work for as many people as possible. and Googlebot. Mobile accessibility is a thing that we have to think about. We should make our websites work from a screen reader on a phone. It's kind of a no-brainer now that I've realized that, but at one point I actually thought, oh, that won't matter. We don't need to make our mobile web pages accessible. You should, because you have a screen reader in your pocket all the time. It's pretty useful. And then lastly, for general accessibility, software testing is really useful for this. So what if, when you're creating a project, you could check whether you're about to deploy code that would fail an accessibility test? That might be kind of useful if you can lint for accessibility. And then on the flip side of that, there are methods of software testing that ride on the coattails of accessibility. So I know in iOS development and Windows development, sometimes you can get testing to work by way of accessibility APIs. So it's pretty awesome if you can make accessibility a win for multiple groups and multiple purposes. So checking in on our project, how's it going? We've been working for a while. We've got this cool prototype we're presenting. Just want to keep in mind that we have an audience that might have different needs than our own. So project's still going really well, but we don't quite know yet whether they're going to be able to access it. So we'll come back to that. So web components. They're a set of new standards. We're super excited about them. There's multiple parts to this new standard moving through the W3C. HTML imports, templates, which we're going to look at a little bit today, decorators, I don't really use those yet, but custom elements and shadow DOM are super important for creating web components, and we're going to look at those today as well. So why are we excited about web components? It's a new approach to building HTML and web pages that I think we are just super excited to try something different. We aren't waiting on browser implementers. So the HTML5 stuff came around, and it was really cool because we have these new range inputs, and we have new elements that we can use that we don't have to go and script everything with JavaScript. So we aren't waiting for browser implementers anymore because we can create our own widgets that have that same native effect as these new elements that get rolled out every so often. Not having to wait on a browser for that to be able to create your own is pretty exciting. Web components provide a way to minimize conflicts. And the way that I explain web components to people who aren't familiar at all is that it's kind of like an iframe, in that you are creating a sandbox for your JavaScript and your CSS so that it is encapsulated and it's separated from the rest of the document. So encapsulation, to me, is the biggest win in web components. And that's kind of getting into where my questions about accessibility came in, which was, all right, we can create this sandbox so that CSS can't go in or out depending on what styles you're defining, but what happens to a screen reader? And that's really where I started wondering, what is going on here with web components? So I started digging in a lot more, and it became really interesting. So diving into the shadow DOM specifically, which was one part of that spec, shadow DOM encapsulates a DOM subtree. And we're going to talk a little bit about what a subtree is. It has this idea of implementation versus interface, meaning that you can implement a single tag, but there's this whole interface behind that you didn't have to implement, which is pretty awesome. Like in the case of the range input, it has multiple parts to it, but all you're putting in your HTML is one input tag. Shadow DOM is not a shadowy underworld organization, which it has a pretty creepy name. So this interface versus implementation. A good example that we actually see and use on the web is a video tag. And we can see here we have a screenshot of there's a video I just found last night actually of a goat named Gary, and he was accused of eating flowers outside a museum in Sydney. And so we're looking at a screen capture of the video with the controls, and then I have the dev tools open. And in the latest Chrome, you can turn on this flag to show shadow DOM. You're probably aware of it. Once you've enabled that, you see how widespread Shadow DOM usage is on the web. It's on text areas, it's on form inputs. Anytime that we have this element that we can drop in just an implementation, it has all of these other things that it comes with that we didn't have to build. We didn't have to create the inputs for these play and pause buttons or the range for the volume slider. But it comes pre-packaged and it's all wired up and we can use it, and that's awesome. So the whole idea with web components is that we could create our own versions of this, which is super cool. So some important terms. The document object model. I mean, we've all used the document object model, but what is it really? It's an object-oriented tree representation of an HTML document. So each component of that tree is a node. Nodes can be groups, nested groups, and when they become node trees or subtrees. So getting into the Shadow DOM specific stuff, a shadow host is the element that hosts one or more Shadow DOM trees. So you have basically your video tag. That's a host for a Shadow DOM. And you can have multiple trees that you shove in there. This idea of encapsulation in web components and Shadow DOM, the specific term for it is the shadow boundary. And that is the line where scripts and styles don't cross. There are some exceptions and there are some backdoors. But for the most part, that's the whole idea, is that if you define an H1 in your web component, it won't affect the style of an H1 outside of the web component, which is pretty awesome, because if you're working alongside somebody and they've written some really general CSS and it screws you up, well, wouldn't it be nice if you could both be as general as you want in your CSS, but you don't run into conflicts? So a shadow tree is the actual subtree that gets inserted into the shadow host. And then finally, the shadow root is the root node of a Shadow DOM subtree. And this was all stuff that I kind of knew, and I read a little bit about these terms, but the more I really dug into what's happening here, these things kept coming up. So it was important, at least for me, to understand what is the DOM? You know, what are these node trees? And actually, they come up a lot, not just in HTML. So a little more about trees. They resemble nature. This graphic is from a book on Scheme, which I think is really interesting. So we have a root node. We have branches that come off of the tree. They have nested node groups. There's nothing here indicating a shadow boundary or a shadow tree, but it's a data structure that we're pretty familiar with already. So we're going to look at some Shadow DOM. So I have this really simple document, and it has a couple of headings. It has a paragraph, an image, and a link in it. So I'm just going to look at the source and see what does this look like? It looks like a normal document. There's no outline. There's no indicator that anything other than a regular document is happening here. So if we look at our HTML source, we can see that it's just some pretty normal code. We have a template tag. That's one of those new items in the Shadow or web component spec. And inside of it, we are defining some style. We have a heading, a paragraph. Inside of the paragraph, we have another template type tag that's content, and it has content inside of it that says meet popsicle. So that's a little weird. We didn't see meet popsicle on the rendered web page, so what's happening there? If we keep going, we have the image, and then down here at the bottom, we have a custom tag called goat stuff. Pretty sure there is not a goat stuff tag already. The only requirement with web components and custom elements is that you add a hyphen in the middle. So the word before the hyphen is effectively a namespace. So I'm calling the goat namespace, just saying. So what's going on here is that we have one word in our shadow host. The goat stuff tag is our shadow host. We have a template that has a bunch of stuff in it that we're going to grab and then insert into our custom tag. But one thing we haven't really figured out is, what is this meat popsicle business? So if I go back to our demo, we can see it says I am a goat. It's got the image. So if I go and look at it in the dev tools, make this a little bigger. Okay, so this is a little different representation because this is after JavaScript has run. So this is after your HTML has been affected by JavaScript and CSS. It's a different representation of your web page. So we drill into this goat stuff tag. We can see we've got a shadow root. We've got some style. We've got a paragraph tag. It's the same stuff. We've got this content. It still says meat popsicle, but I'm not seeing that. I'm seeing in the goat stuff tag, we have goat. So what's happening here is that goat is being projected into the content tag, and that is what gets rendered to you. Even though after rendering, we're still seeing meat popsicle in the dev tools, but that doesn't ever get rendered to the screen. So that's one of the really, to me, one of the strangest parts about Shadow DOM. But I am still curious what's going to happen in a screen reader there. Not quite sure yet. So, to get that Shadow DOM stuff to work, Polymer is a really awesome polyfill, and they have a set of components that you can use. But before I got into that, I wanted to build it myself. I wanted to know exactly what goes into this. I want to learn it really well before I go and add a bunch of tools that somebody else has made. So in the latest Chrome, I could create a little bit of JavaScript. I'm going and grabbing the contents out of a template tag. I'm creating a new element. So you extend a basic HTML element, which we're seeing here with object.create, and then we're copying the prototype just from a very generic HTML element. When that element gets created, which we've registered down here on the bottom, we register the goat stuff element, and then we set its prototype to be this goat component. When that gets created, it has a callback function, and that's when you can start doing stuff to it. That's when you can change the content. That's when you can enable some of these backdoors for your scripts. You can bind events. And Polymer does a really great job of abstracting this away, but, and I'm finally ready to move to that now, but it was really useful to go through and see what is happening. So about that boundary, I mentioned there are some backdoors, and this stuff still trips me up a little bit. I think it's really odd. So when you create your CSS for your main document tree, if you define a font on your body tag, you would think that the Shadow DOM would be encapsulated so that it would not get the same font face, but it does. That's one of the few styles that actually goes past the boundary, so it's a little unexpected. But there is this JavaScript property that you can set called reset style inheritance, and that will wipe out any of those cascades that go through the boundary. There's also apply author styles, which allows your parent style sheet to go into the Shadow DOM. So you, as the document creator, have that control. You can say, do I want the styles to go in or not? If I'm implementing some widget that some third-party developer created, I want to be able to override their styles, but I don't want them to be able to override mine. So you have this control as the parent document owner, and these are the tools that you can use for that. So going back to the trees and looking at, if we have a shadow host, and this image comes right out of the Shadow DOM spec, which I've had open in my browser for 6 months. So we have a shadow host, and this image is describing that it has children in it, which actually get replaced by a shadow DOM, which we're showing here on the right side of the graphic. There's a shadow boundary, so that's indicating the encapsulation. And then we have the shadow root, which is the parent node of a bunch of children. And the Shadow DOM spec is actually really awesome as far as specs go. So we looked at our demo, but we didn't answer whether it was accessible or not. It looked okay. It looked like a normal document. So we're going to go back to that demo And I'm just going to start tabbing through. I could tab onto the link. That's cool. If I turn on VoiceOver.
Basic demo. Shadow DOM accessibility window. Basic demo. Heading level 1. Shadow DOM demo.
We got a heading.
Heading level 2. Main document.
That's still the main document. So now I'm going to go into the Shadow DOM.
Heading level 2. Goat stuff.
All right. We went over the boundary. It read it.
I am a goat.
I'm a goat.
Fancy goat image. Goat simulator gameplay hands-on. No joke. All goat. Visited link. VoiceOver off.
So that's awesome. We went into the boundary. Cool. So that's kind of like, all right, it's accessible. And it worked. But why did that work? Why did that work? And that's what I wanted to know. So a little bit about web browsers and screen readers and how they work. The difference between our view source and our rendered markup was that the web browser takes your HTML, it creates the objects from the markup, that's what the DOM is. The DOM has been altered by your CSS, your JavaScript, and ARIA, or Accessible Rich Internet Applications. If you use any roles or states or properties, those affect the tree that gets created. Web components also create a subtree, so that is added to the larger tree. The screen reader uses the objects in the rendered DOM, so it gets one big tree. And that is called an accessibility tree, and that is what is presented to the screen reader user or a screen magnifier. I thought that was really interesting and was pretty key to what made Shadow DOM work. So how do you make accessible web components? You write accessible code. It's pretty simple, but we forget that stuff sometimes. And if you don't, you might get knocked by this goat, like this newscaster lady. Boom. Okay, so how do you write accessible code? Little recap. You use native and semantic HTML. So use headings. Inside of your web components, use native and semantic HTML. If you have a button, make it a button. Don't make it a div. Like, just try to use the HTML the way it was intended, and you'll have a lot better time. You want to make readable text content. You want to provide visual feedback. You need to use focus management and use JavaScript events to send the user around your experience. And then finally, you can use ARIA to fill in gaps where HTML doesn't quite meet your needs, but you should have exhausted all avenues with native HTML first. So one last look, and I'm actually going to use a different screen reader this time. I'm going to use NVDA, which is on Windows, and I'm going to use VirtualBox for that. And one quick note, I was going to use JAWS, but I had trouble getting it installed on this machine. But if you're going to test for accessibility, you can actually use the demo version of JAWS for 45 or 40 minutes at a time. Just a side note.
Explosions.
But NVDA is a free one. So I'm going to hover over things and it'll read it.
Explosions.
Explosions. And a little background of this component actually was I was thinking, if I'm going to make an encapsulated component, what would be useful? And I thought that a single button that was kind of like a nuclear detonator that you could engage and then have it expose another kind of a button, that would be kind of cool, but I didn't know how I would create that. So I made a little, it has a certain part of it you have to slide to engage it, it exposes another button, and then explosions will happen.
100, are you sure?
Are you sure you want to engage it?
Choose a percentage between 0 and 100, 0%.
All right, I'm going to do it.
Yes, really. Yes, are you sure?
Are we sure?
Yes, really.
All right, really, we're really sure.
Main landmark, yes, goats on metal GIF.
So what happened there was that it was reading out the parts of the component. So the encapsulated parts get read aloud just fine. And that's because you get presented with one big tree. And I thought that was really cool. I learned a lot about how screen readers work. I learned how browsers work. And it really transcended just something about accessibility. I thought that was pretty awesome. Get me out of here.
Firefox.
All right, so one little note about support. Polymer has this great matrix up on their website to show you, and I just added their polyfill to extend support beyond just Chrome and Firefox. But IE10 is as far back as you can go. So just a quick recap. We want to develop for the ideal, and we want to develop for people, because why else are you doing it otherwise? Web components provide encapsulation. Shadow DOM is accessible, and it's accessible because screen readers utilize the DOM as rendered. And finally, you want to pick the right technology for your audience. So how'd you do on your project? Well, your executives came in and your project manager who couldn't see the screen, and they demoed your project just fine because web components are accessible. So you nailed it. And that's it for me.